today, I am very, very pleased to welcome our Principal of MPW London, John Southworth. This will be, as I say, around the specialist programmes applying for engineering courses, part of our programme. Prior to joining MPW as Vice Principal in 2014, John was a Major in the Army and he was Director of Co-Curriculum at the First School and most recently Principal of Lansdowne College. Regarding this session, and perhaps most importantly, John read engineering at the University of Leicester and subsequently gained an MSc in Defence Technology from the Cranfield Institute of Technology. It's an absolute pleasure to be introducing one of our principals to you. So, John, please take it away.
Thank you very much indeed, Simon. Hope everyone can hear me okay. Without further ado, let's try and move this on. Okay. So Simon's giving you a quick sort of introduction about sort of who I am, sort of a bit of a background. I suppose that the other thing I'd say is, as well as being a principal, I've taught design technology, systems and control, mainly electronics and mechanics, for about 20 years. Sadly, not been teaching that most recently, but helping out some of my students with using Arduinos and ARM embeds and that type of thing to do some basic programming and control systems. But I have learned from my time of teaching design technology that is probably the key to many of my students gaining access to excellent universities. The fact that they have got some engineering experience or practical experience, you know, not just having done maths and physics, but practical experience in some real-time electronics, real-time mechanics, and perhaps I can cover that later on as we move on. So, what is engineering? Well, it's a good question because it does embrace so many different things. But I think the statement at the top really sort of tells you what it is. It's the practical application of math, science and technology to design and create machines, processes and structures. If you look around you, I would challenge you all now at the beginning of this time to think around you, anything you can see or touch or feel that has not had engineering involved in it in some way. And so maybe at the end, if any of you can come up with something that they think has not got some kind of engineering or technology involved in it, I'd be delighted to hear. When I've done this presentation before, I've had a couple of good suggestions, but I think I've talked them round and we haven't found anything yet. So let's see what we get onto it. But as I said, it's much more, isn't it? It is about problem solving. So most engineers are problem solvers in some way. They are looking at the environment, they're looking at things around them, and they're trying to design things that are going to make people's lives better, easier, more straightforward, and more exciting in many ways. So you do find engineers working in advanced prosthetics, creating new materials. Materials being probably one of the key things, because again, all these things that engineers manufacture or make or design at some stage will all involve some type of material. And over the years I've been teaching, just over the years, in recent years, the advancement in advanced materials has been quite remarkable. And you can now build structures that would never have been conceived maybe 20 or 25 years ago because of these smart materials that have strength and manipulability whilst being lightweight and flexible. So then we got a few other things: investigating engine efficiencies, alternative fuels. So again, the younger generation now quite rightly are looking at alternative sources of fuels, and so wind farms, sun farms and so on, wave farms are the way ahead to create renewable energy and renewable sources of energy, so that we can stop the large production of greenhouse gases through burning of fuels like coal and oil. And in that I also include nuclear industry, because I think that is also the way forward. So if you can combine nuclear energy alongside renewable energy, you suddenly have a solution to the world's problems whilst not burning coal and oil. So other things, constructing bridges, that's a standard thing which a lot of engineers think of when they start thinking of engineering, build a bridge. And in fact, one of the first things I would always do with my young pupils when I was teaching them the design technology system was to give them a pile of aluminium strips and some nuts and bolts and try and get them to develop a bridge. And then we would test it to destruction with large weights. And it always created some interesting designs and interesting results. Actually, when I went to university, it was interesting because the very, very first exercise that I was given as a potential engineer was to design a bridge and to think of all the stresses and strains and forces that act on that bridge and what then makes you design a bridge in a certain way. And of course, if some of you, I'd look up on YouTube if you've got a moment, a bridge that was built in San Francisco many, many years ago. Brilliant, brilliant bridge, looked fantastic, brilliant design, beautifully engineered. But on one particular day, the wind was at a particular speed and it resonated with the bridge in such a way that the bridge started to swing and sway and literally demolished itself because the resonant frequency of the bridge was equal to the resonant frequency of the wind on that particular day. It was an extraordinary video, and I would certainly suggest some of you look at that and think, well, there's a brilliant looking bridge. Why did it fall down? Then we go on to space and satellites, down to cell membranes. And in all these things, engineers are using maths and science to find the most amazing solutions to some of our world's most complex challenges. So there we go. That's the background to what it is. And that's why engineering is so exciting. And that's why I'm always excited to talk about it, because I think it is certainly a career that it is very worthwhile to so many people. So scientists study the world as it is. Engineers create the world that has never been. And I think that's probably true in so many ways. Engineers are trying to look into the future and create things that you've not seen before, find things you've not seen before. And if you watch some of these amazing TV shows, science fiction shows, some of them you would have thought, no way will that ever happen in my lifetime. But some of those amazing science fiction shows, some of those have now become reality. I'm not quite sure whether we'll ever get to the time of Star Trek when we can press a button and say, beam me up, Scotty, and we get sort of transferred from planet to planet or city to city. But some of those things that have been planned over years are really happening now. So why engineering? Well, everything, as I said before, everything we do, everything around us is engineering. And I would again challenge you to find anything which is not. It's fun. I think building things, making things, what I call reverse engineering. So taking things to pieces, I think is probably one of the crucial things you can do if you are going to be an engineer. Let me give you an example. When I was at school, we had an old car. And from the age of about 12 or 13, actually, we would then take this car to pieces, strip down the brakes, strip down the suspension, strip down the engine, the carburetor, the alternator, and find out how it had been made and how we could perhaps think about ways of improving it. And then we put it all back together again, having cleaned it and got the car reworking again. And then we sort of made a mock-up so people could then work on it on a regular basis by taking things to pieces and seeing how they all worked. But removing all the oil and all the grease, of course, so it didn't get everybody dirty like we were. I must say one of the greatest fun things I found about engineering is getting sort of covered in sort of oil and grease as you're taking an engine to pieces. It's I find that really good fun to do. And as such, over my years as a young man, I rebuilt a number of cars. And one of my most recent things, I rebuilt a couple of Porsches over my time, which has been great fun to do, but also has used the skills I gained on my engineering courses, my engineering studies, to help me make those cars safe and roadworthy again. So it's interesting. That's everything we do, I think, is interesting in it. Innovation is also one of the crucial things. So if any of you have got also skills in creative arts, I think you can use those skills very, very positively if you're going to go down an engineering degree. I'll come to this later, but I've always thought that the best combination of subjects for engineers is maths, physics, and art, or art of some type, some creative art, because as an engineer, you are designing something, but actually you want to design it so it's got also the aesthetic appearance as well as the functional appearance. Some engineers who can just be quite blinkered and use maths and physics to create something, those things are sometimes rather boring. They don't look really very nice to look at. But actually, if you then bring in the creative arts side, you can also create something which is visually pleasing as well. And the final thing there, it's sort of creative and future-proof. We are making things as engineers that are going to secure our future. And I think you, as the younger generation now moving forward, having just got through one of the most original and amazing years in your lives, where you have helped, I think as Boris Johnson said in a recent speech, you've saved so many hundreds of thousands of lives by staying at home and stopping the spread of this awful disease. Well, you have future-proofed the world as we're going forward, and you are going to be the innovators and creators of that future. So I think I was trying to join together this by saying, an engineer is a dreamer, innovator, inventor, researcher, problem solver, and a creator. And I said, and it's central in my view to everything in the world as we see it today. So what types of engineering are they? Well, I've covered a few of those, but this is sort of I suppose, the general list of the main areas of engineering that some of you might be considering studying. And there are courses at most universities in each one of these disciplines. So they go from the aerospace industry, which is working on obviously aeroplanes, through to space, where you might be working on lunar modules or space modules, working for the European Space Agency or working for NASA. And then in between, there's so many other things. I've always been a big fan of marine engineering. I think some very good courses down at places like Plymouth and Southampton, and up in the north in Newcastle, and in Wales, Aberystwyth and so on, where you could do some amazing marine engineering courses, if that is a side of it that you enjoy. But in all the engineering courses you do, it will include materials. It will include energy sources. There will be some form of electronics. There will be some form of information system. There will be some, in some cases, some sort of chemical side as well. So engineers do tend to be all-rounders in many aspects of engineering, but then going down the specific route at a later date. So the engineering course I did, when I did it many, many years ago, I did 2 years of general engineering, and then I specialised in the end in communications and electronics. And that's where I've carried on using those skills throughout my life. But you might have a different route you'd go down, and depending on which route you go down might then depend on what A levels you're doing or what A levels you might be considered doing. So that comes on to subjects. It's sad, isn't it, where I have to put at the beginning of a slide, maths, maths and maths. Well, that is it. The majority of, the vast majority of engineering courses will insist on you having maths as one of your subjects. There is so many calculations that you have to do on an engineering course that you've got to have the full skill at mathematics. And so there are, I don't really know of any engineering courses currently that won't insist on you having maths as one of your A levels. And And it is important then to get a good grade in that maths course. So if you are doing maths, work hard at it. And as well as maths, I would say practice. And if in doubt, practice more. And when you finish practicing, practice again. Because that's the only way you're going to get good at maths and understand patterns and systems. And that will help you in getting a good maths grade. Likewise, most universities will require physics if you're going to do most engineering courses, and then a third subject. Now, this is where the debate happens. What will be that third subject? I've already mentioned that I am very, very keen on a creative art. And certainly if you went into architecture, they would want you to have maths, physics and a creative art. So likewise with engineering, I think because there is so much crossover between architecture and engineering, certainly in mechanical engineering, so constructional engineering, that I think having a creative art is an extremely good thing to have. But clearly, if you were going to study chemical engineering, then absolutely, you've got to have chemistry. And so if some of you are doing maths, biology and chemistry, for example, and you might be thinking one of your options is to go into medicine, actually, you could also use that to go into chemical engineering or biomed engineering. So don't worry if you suddenly think you've changed your mind in your career path and you're now looking at doing something completely different, but use the subjects you've got to the best effect you can. Having a language as a third subject could be incredibly important because it makes you international. There are some huge engineering companies, for example, in France, which are their renewable energy systems are probably some of the best in the world. And I think that if you've got a language like French, you could go and work for one of these multinational engineering companies, and there is a real shortage of good engineers. So jobs are there for people like you. Another language that is forgotten is computer science, because computers use languages. They might be C#, C++, they might be whatever Python, whatever language you're used to using, but it is a language. And so having that third subject, which could be computer science, could be incredibly useful. I was told by the director of admissions at Oxford a couple of years ago when I went to visit, and I asked them how did they sort of choose students to get the best degrees, because they want everybody to get a first-class degree. And how do they choose them for subjects like computer science and engineering? And actually, he said they looked at their grades in their modern language grades when they did GCSEs. And there was a direct correlation between a student getting an A* in a language such as French or German and getting a first-class honours degree in subjects such as maths, computer science and engineering, because it's all about following rules. And if you can follow those rules, you can do extremely well at languages and certainly in a computer language. And then there is finally, of course, the debate about further mathematics. There are very few courses that insist on further maths and physics as your three subjects. Quite a few of the courses, Imperial, do definitely prefer you to have further maths alongside maths and physics. I'm doubtful about it. I think yes, all courses now try to bring all their students up to the same level of mathematics. And so even when I joined a university course, in the first term, we did maths. That's all we did, to bring everybody up to the same speed, because maths is so important to everything that you do thereafter. In some courses, of course, you went to do engineering at Cambridge, for example, you would end up doing maths for about 2 years, because they think that maths is the only thing you should study if you want to be in engineering. And so most students from Cambridge then go into sort of theoretical engineering rather than sort of hands-on engineering. But if you go to other universities like Imperial or Southampton or Exeter, Bath, Loughborough, those type of universities, you'll be doing hand-on engineering at a very, very early stage, and they will not insist necessarily on the further maths subject. But if you are doing maths and further maths and physics, don't worry, it's going to open up all the doors for those engineering courses. My only concern is that then you perhaps haven't got some practical engineering experience, and that's what you need to get over the coming months. You need to get some practical experience. Just on that, if you are not already learning what a gear train is, how does a gear train work for mechanical engineering, if you don't understand, for example, how software works or how renewable energy works, there is a plethora of brilliant YouTube videos on engineering sites, and I would certainly strongly recommend that you all go and look at some of those videos, because if you don't understand what a gear train is, if you don't understand how transmission works, or how a solar cell works, or just simple things that are in everyday life, then at interview, if you get to that stage at university and they ask you some of these basic questions, you are going to struggle. And it's not just covered in maths and physics, it's actually the practical application of technology towards engineering. So please do look at those things. Certainly when I do Cambridge mock interviews, I will throw in a number of questions about the practical aspects of engineering, because that's what they do for the Cambridge course. And if you are just a mathematician, you're really going to struggle with those. You do need to have some kind of practical knowledge. So the university courses. So the top courses, in my view, are there in that list. Interesting, you might say, why have I put Oxbridge third? Probably because what I just said earlier, the Cambridge course, you will spend most of the first 2 years doing mathematics. Oxford is slightly better. You probably spend a year doing mathematics and then they move on to engineering. But in my view, this is very much a personal view, Imperial is probably the best in the world for engineering, probably followed by Oxford and Cambridge if you look at this at various league tables. But one of the ones that I'm really pushing hard is Southampton. And I don't have sort of shares in Southampton, so that's not where I'm doing it, but I'm a big fan of their courses. I think they feedback from students who've gone there has been exceptional. They run a fantastic suite of engineering courses. And then clearly you've got the other ones, Warwick, Manchester, Edinburgh, Bristol and Bath, and also to add to that Exeter, Loughborough, as being really good quality universities that are going to get you a brilliant engineering degree. And they will be the universities that will cover almost every one of those areas of engineering that I covered earlier. So that if you are looking at a particular course, certainly that suite of universities is where you should look at first. Look on the UCAS website. Later on, I'll show you the MPW guide. If you haven't got a copy, we can get those to you. So you can look at those and see what kind of courses they run. But the UCAS website is definitely the best way to go, first of all. Now, most of these universities will need A-star AA in your 3 subjects, and you don't need more than 3 A-levels. Some of you might well be studying further maths, physics and chemistry. That's fine, but you don't need more than 3 A-levels. They will only offer you based on 3 A-level grades. The way around that is perhaps to do an EPQ and do your EPQ, the extended project qualification, do that on an engineering topic. So the personal statement I'm about to show you in a moment, the student there was doing double maths and physics and applied for Imperial, but through me, he did his EPQ, working on a practical subject, working on sort of resistor grids and matrices. And actually, when he went for interview, he could talk about the practical application of engineering through the EPQ he'd done and the work he'd done with me. And he's now in his 3rd year at Imperial, studying for his master's in engineering. Most universities will want a minimum of ABB, and that's always been the case for engineering. Engineering is a tough course, and I said you've got to be good at maths, good at sciences. So if you want to go to a top university, you've got to go and get good grades to get on those top courses, but it's worth it. But I said to you earlier, there is a shortage of engineers in this country and around the world, good quality engineers. So universities have been very well known to drop their offers. So students who have been asked for 3As at good universities like Manchester, Edinburgh, have sometimes got in with actually ABB, even though their offer originally was for 3As. So don't be disheartened if in August, if those who are waiting for results, you don't quite get there. Go straight to your university. Tell them how keen you are to go to their university and why you want to go on that particular course they're offering. Do your background work on the course content, and when you call them, mention some of the things that are in that course and the reason why you want to go and do that particular course. That will set you above everybody else, that you have got the knowledge of their course and that's why you're going for it. And I've so many examples of students where I've got them to go and do that, and immediately the university says, yeah, okay, we'll take you. You clearly understand the course. We like that. We're going to take you, even though they might have missed the course grades by 1 grade. Okay, so universities, how to choose the key thing about this university application process, though, is although I've listed there before the top universities and the universities you might aspire to, do not choose your university first. Choose your course first and do research on the course you want to do. It will pay great dividends in the future. You do not want to go on the course that after the first 2 terms, you're suddenly realizing is not for you, that you're not enjoying it, and you're not wanting to get out of bed in the morning to go to your lectures. As engineers, you will have lectures at 9 o'clock every morning, and you do lectures all the way through the morning, and you'll be in the labs in the afternoons. It's not like a humanities subject that maybe have 3 or 4 hours of lectures a week. Engineers work very, very hard. Probably the only people who work harder at university are probably the doctors, the dentists and the lawyers. But engineers are always in lectures or they are in the workshops and labs. So be prepared for that. So the key thing is to make sure you've got on the right course, because if you're going to be going lectures every single day, all day, you've got to enjoy what you're doing. Once you've found the course you want to do, then you choose the universities that run that course, and invariably some of the universities I listed earlier will be on there. Then ensure you have a wide choice. Now, clearly, if you are hovering around the sort of the A, B grades in your A levels, and that's where you think you're going to be, there's no problem at all with having an aspirational choice of where you'd really like to go. So someone who's offering A star, AA or 3As, put it as one of your choices. Then have 2 sensible choices, which are going to be around about the grades that you're expecting, and then maybe have 1 or 2 backup choices. So something which might be 3 Bs or 2 Bs and a C, just in case you don't quite get those grades. Now, clearly, when you have got those 5 choices on your application, that's going to be great if you then get 5 offers. You can then make your firm choice and your insurance choice, and your firm choice might not necessarily be your aspirational choice, but as you've got plenty of time before you make those final choices, having got those offers, by then you should have a much better idea of whether you are going to meet the grades you have been predicted or the grades you need, because you're probably making those final choices in sort of May time of the year when you might be going to the university in that September. And at the moment, okay, there are very few universities running any type of real open days as we do in the old days, but there are quite a lot of virtual open days going on. So do get onto those, do go and have a look and see what they've got to offer, so that you can, again, make your choice of which university you want to go to after you've chosen which course you want to go and do. Some of those virtual open days are extremely good. And admissions tutors love to hear from people like you. So do contact the admissions tutors, have a chat with them, tell them what your interests are. They might be able to steer you towards the right course, which is designed for you, rather than the course you think is the right one for you. So personal statements. I hope that many of you, if you're applying for university this year, have already started to make a start on your personal statement. If you haven't, start now. Don't hang around. There's no time to spare, because it's going to take you quite a long time to get your personal statement right. And the first thing is make it personal. it's no point just finding a personal statement on YouTube or on some student's website and copying it, because all the universities use a plagiarism software, and they will easily spot when the personal statement is just copied and pasted somewhere else. Do add things that they are going to want to read. So you should be reading articles on engineering. There's plenty of articles in every newspaper on a daily basis about engineering, but get a good quality engineering magazine, look online for articles. And I said, look on those YouTube videos, and I mentioned on engineering concepts and future designs and products. If you want to be an engineer, get the knowledge of what's going on in the engineering world. Clearly, your personal statement needs to focus on maths and science. Almost every university is only really worried about whether you have got the ability in maths and science. They are also wanting you to demonstrate that you have read the course content. So if you're applying for a degree in marine engineering, your personal statement needs to be talking about something about marine engineering in your personal statement. Otherwise, you would just be applying for any general engineering course. It could be you are applying for a general engineering course, so you need to make that clear that you have not yet decided quite which field of engineering you want to go into, but you'd like to go on a general course first of all before specialising in your final year. You need to demonstrate you've got an inquiring mind. So that's why I said, if you are doing something like taking an engine to pieces, or you're doing some electronics, you can buy very, very cheaply some microprocessors. You can buy kits. There's a system called Pickaxe. That's P-I-C-A-X-E, Pickaxe. If you look that up, you can buy Pickaxe kits for, you know, £10 or £20. It's a small chip on a board, and it has a number of connections. You can connect small motors to it, you can connect LEDs to it, you can connect lights, other lights to it, a whole range of things you connect to it, and you can make a control system. And if you can demonstrate you've done that, and you can then mention that in your personal statement, again, that has shown you've got an inquiring mind, and you're starting to demonstrate an understanding of engineering, of computer control, and the like. Do include any relevant work experience. I know work experience is difficult to come by at the moment, but you can do online work experience. It's not essential that you've done work experience, but I would say if you are interested in engineering, you need to have gone and found out something about it to check that it is the right career path for you. So contact a couple of engineering companies, local ones who are doing just making metalwork or doing computer design or a car company. Just contact them and say, can I have a chat about what you do and how engineering impacts on what you do in the world of work? There are some Head Start courses, and the best ones around again are Southampton, Bath and Bristol, and there's also a similar one at Cambridge. Now, again, I don't think they're going to be running them at the moment, but they might be running some online courses through universities that might give you an insight into what those university courses have to offer for you were you to apply to them. And I said, fine, I've already covered this, but mention any practical work you've done. So I said reverse engineering. You can't go wrong with that. Take something to pieces. If you've got an old radio or an old Hoover or a television, okay, make sure you've taken off the plug. You don't connect it to the mains. Take it to pieces. See what's inside it. Have a look at it and try and identify the things that are in there, and you'll find that will be extremely interesting for you. The final thing, and this is most important. For everything you say in your personal statement, ask yourself the question, so what? And you should be able to ask so what normally about 3 times, and then you get to the end and you think, okay, I've answered that. So if you say, I want to do engineering, so what? Well, I want to do engineering because I really enjoy maths and science. So what? Well, actually, I really enjoy maths and science, but actually in particular, I enjoy Fourier transforms and electronics and computer control. And as such, I've now been actually taking apart a computer and I've been trying to improve the memory on it, looking at the processing, looking at the resistors and capacitors that are in that system. So what you're trying to do is develop this picture of yourself that shows that you are inquisitive and that you are always asking your question, so what? Because if you make a statement, make sure you can back it up with some form of words. So here's an example of a personal statement. This was the young man I mentioned who's currently at Imperial. And I think you've got to be quite careful when you start off these personal statements. You know, curiosity led me to discover an alternative, more interesting way of using my Android phone. Well, straight away, you're grabbed by that statement. Someone's looked at their phone and thought, what can I do with it? And so he started digging into the system. He looked at the code. He then started to change things in it. And then this is what's really driven him towards doing a degree in electrical engineering. So he identified that Imperial was the university he wanted to go to. He identified because he looked at their electronics engineering course and it ticked every one of his boxes. So he then focused his first personal statement here on the course that he wanted to go on. So he then looked at this project idea, and here we go. He then did this. He then did this. Oops, I've gone one slide too far. Sorry. He did this. He made a 3x3 LED controlled cube, and it was also controlled by a microphone. As you then made different noises into the microphone, different amounts of LEDs flashed and different color combinations, and it was a great little project. But what he was doing is he was developing something and demonstrating that he had an understanding of basic electronics before he applied for this course. So it then says what his idea was of what he designed, and he used it using an Arduino. So again, I mentioned buying perhaps a pickaxe system, which is quite cheap. You can also buy an Arduino kit. You can buy quite an extensive Arduino kit for around about £100. It will have a lot of components. It has the software just to plug it into your computer, as does the pickaxe. And you can design some great little systems using an Arduino, and it's great fun. Here he said he added a decoupling capacitor. Some of you won't know what that means, but the fact that he could talk about that in his statement, it meant that when he went for interview, they said, tell us what you meant by that. And of course, he knew exactly what it was because he'd done it practically. He'd seen what happened when he didn't have the capacitor on the system and when he did have it on the system and what the difference was. And that was absolutely crucial. These spikes, if you've got a spike in a system, a computer system reads that as a positive, i.e. a 1 rather than a 0, and it will start to change the way that system works. So you always need to eliminate any spikes in voltage so you don't get erroneous readings on your computer system, which causes errors. And then he talked about how he enjoyed it. He then went on to start to say, I started researching the course for a while ago, and he again looked at his laptop and how he did that. He talked about his A-levels, and then he said how at school he was part of a gifted students in physics, and it was a specialist class, and he did a lot of work in that, and he went to an international fair, and he's been looking at cars and kinetic energy. So everything in this personal statement ticks all the right boxes. And for a admissions tutor, it really gets you asking questions. I really want to meet this person. This person is someone who's gone out, done something, made something, reversed engineered something. He's interesting. I want to talk to him. I think he could be a great future engineer. And I said, that young man is now at Imperial in his 3rd year and doing extremely well. I mentioned work experience earlier, and I said it's not essential, but it's useful because it gives you an insight into what you might be doing. So I said, do work for any type of engineering company. And it's sometimes quite a few of these courses run an in-service, an in-degree course where you can do a 4-year course, and normally your 3rd year is going to work in industry. Now, I think that is a brilliant, brilliant thing to do, because if you go and work for that company for a year and you do really, really well, the most likely scenario is in your holidays, on your next year, they'll probably say, come and work for us over the Christmas or over Easter for a week. Keep to know us, and when you finish your degree, you've probably got a job waiting for you because you've already demonstrated in a year, you know, what your capacity is for work and how good you are at engineering. So I think the degree courses that have an industry placement are very, very worthwhile indeed. We do have this a book that is our engineering courses book that we produce in MPW. That will cover an awful lot of the things I've just said and give you a lot of more examples of personal statements and a lot of examples of different university courses. But again, you can't really beat going onto the UCAS system. So on that note, I've been sort of going on now for about 40 minutes. So I think that's probably enough from me. Thank you for your attention, and I'm very happy to take any immediate questions, or you can fire them at us and we will ask them in longer time. So Simon, over to you.
Thank you, John. Thank you very much. So much information there. So what we normally do, we allow some time now for questions. If you want to unmic yourself and ask the question, that's fine. Or if you want to leave the message in the chat box, that's fine. If there are questions, we give it a couple of minutes. Sometimes there are, sometimes there's not. And then we will go from there. Thanks. Okay, so I don't think we've got questions straight away. We will be sharing the recording of this, as we said, with you all. Thank you very much for coming to day 4. We've had an excellent attendance today, and for now, I just want to say thank you very much to John for spending some time with us today and explaining the route and a bit more detail around engineering. I have heard that presentation before, but I still love it. And it's been very, very interesting. And I'm going to go to San Francisco and look at YouTube now. So thank you to everybody who's attended today. We look forward to seeing you next week. Next week, we have another very busy day. We have masterclasses around economics and physics. We have advanced level maths skills, which is obviously relevant to what we've just been hearing about. We've got the how we look after you and the sort of extracurricular and fun activities that our students have. That's the student panel. And then we have in the specialist stream, getting into law programs and more information about law. So we look forward to seeing you again this same time, same place next week. And John, once again, thank you very much for coming by today. And
thank you very much. Good talking to you.
Bye.
See you for now. Bye for now.